This conference will now be recorded.
Very good evening, students. We have been discussing PUIQs from JEE Mains papers. So today we'll be finishing this paper 20th July 2021 shift 1. So let us read this question. So this question says entropy of any system is given by S is equal to alpha square beta ln mu kr divided by j beta square plus 3. Alpha and beta are constants. Mu j k r, they're actually, see, mu is moles, j is mechanical equivalent of heat, this k is Boltzmann constant, and this r is gas constant respectively. And s I have to take as dq by dt. Then we have to choose the correct, okay, choose the incorrect option from the following. We have to see which one is incorrect. Okay, let us see what is s. S is given as dq by dt, right? This is specific heat, dq by dt. So dq by dt, look, this is having unit of joule, SI unit, heat. Okay, so this is joule and this is Kelvin. So joule per Kelvin is the unit. Now look, I have been given this expression S is equal to alpha square beta and ln mu k r by j beta square plus 3. So this one is the expression. We have to see which one is incorrect. So first of all, let me tell you, see, the quantity inside ln, the whole quantity has to be dimensionless. Actually, that is the rule. Exponential, any quantity, that will be a simple number. Okay, that will not be any unit or dimension, like that has to be dimensionless quantity, like this one. See, if you are not agreeing with me that this is not a dimensionless quantity, then see, look, this one, this quantity plus 3, so this is a number. So number can be added to a number alone. Okay, any dimensionless quantity can be added to a dimensionless quantity alone. Like if I add a plus b, then both will have to be of same dimension. Okay, so that is the rule. Therefore I can say that this is actually a dimensionless quantity. That means, you know, unit of this quantity must be equal to the unit of j b square. Okay, unit of this must be equal to the unit of j beta square. Now look, what is this mu? Mu is mole, right? And k is Boltzmann constant. Boltzmann constant, actually, see, PV is equal to kT. From here I can say this k will be, see, PV is the work done or energy, I can say. So this will be joule per Kelvin. Okay, joule per Kelvin is the unit of k. So I can write this mu kr, unit of this will be, so this is mole, then this will be joule per Kelvin, and this will also have joule per Kelvin per mole. So J per K into mole. So mole I can cancel, and I get here J square, Joule square per Kelvin square. Okay. Now look the denominator of this quantity, denominator of this ratio. I have J beta square. J is actually mechanical equivalent. One calorie means 4.2 joule. 1 calorie means 4.2 joule. Actually, this is 1 calorie means 4.2 joule. This is actually mechanical equivalent of heat. So this much heat can be converted into 4.2 joule of energy, mechanical energy. That means, if you closely look, this J is a dimensionless quantity alone because both sides, this and this, are of equivalent unit. So I can take this as J as dimensionless quantity, right? And see, if you want to have this term, this whole term dimensionless, then also it is required that this J has to be taken dimensionless. So then from here, if I consider, not to consider, as you know, J is dimensionless quantity, so this will be Joule square. So beta square means Joule square per Kelvin square, right? So beta will be having unit or dimension, you can say, we can say dimension. So both are having same dimension or same unit means like Joule per Kelvin. So beta will be actually Joule per Kelvin. Joule per Kelvin. That means, this is m L square to the power -2 divided by K. K is again Kelvin. Kelvin I can write as theta, or Kelvin itself we can write. So better to go with unit itself. So as we have got, this is Joule per Kelvin, and also so this must be Joule per Kelvin, right? So far what we have got S is equal to Joule per Kelvin, beta is equal to Joule per Kelvin. From this expression, then I can say the alpha square, or alpha is a dimensionless quantity. I can say this is dimensionless. Dimensionless quantity. Okay, alpha is a dimensionless quantity. All right. So if the alpha is dimensionless quantity, then see, let us see the options now. We know the unit of others, like we know unit of S, K, mu, R. So we did not know the unit of alpha and beta. So beta we have got Joule per Kelvin, and this alpha we have got dimensionless quantity. So look here, alpha and K have the same dimension. This is actually not true because K is Boltzmann's constant, that is Joule per Kelvin, and alpha is a dimensionless quantity. Okay. So this is not true actually. They don't have the same dimension. This is not true. So this must be the answer. Let us see the other options. So this option says S, beta, K, mu. This is obviously have the same dimension. This S, beta, mu, R have the same dimensions. Choose the incorrect option. S, beta, K, S and beta find. S, beta. Okay, I understand. So S, beta, K, mu, this will be multiplied. K into mu and R have the same dimensions. It is actually, I think while writing I have written it little bit different way. So this is, see, you look this means what? This comma was not there, I had put. That means, this S beta, S and beta, and K mu along with R, they will have this is joule per mole Kelvin. There is, let me check the correct options given. But anyway, this is, if this is saying that S, beta, K, mu and R, all of them have the same dimensions, then it is not true. But there, this is actually single answer correct questions. Okay, so this is the question. In this question there will be only one option correct. So here we have been asked to find out incorrect option. So this must be typos. Let me check the question once again if I have done some typos. So the question says entropy of any system is given by S is equal to alpha square beta. Yes. So this option is given in this way: S, comma beta, comma K and mu into R. These have the same dimensions. This is obviously true. S is joule per Kelvin, beta is joule per Kelvin. This is also joule per Kelvin, and mu and R. Mu is the mole, so this R has unit joule per mole Kelvin. So mole will strike out. So this is correct option. Actually, this is correct. This is correct. This is not incorrect. This is correct. Okay. So S and alpha have the different dimensions. This is also correct. F and J have the same dimension because both of them are dimensionless quantity. See, alpha and K have the same dimension. This is not true. This is not true. So this will be actually our answer. So what is the answer for this question? The answer is B. Option B is the answer. Okay. All right. Let us go to the next problem. So this question says a person whose mass is 100 kg travels from Earth to Mars in a spaceship. So suppose this is my Earth, this is my Mars. Okay. Neglect all other objects in the sky and take acceleration due to gravity on the Earth's surface as the mass as 10 meter per second square on the Earth's surface and 4. The G is actually 10 meter per second square, as we know, and here G is, let us write, this is G of Earth's surface on the Earth's surface, and this is on the Mars surface. That is 4 meter per second square. Okay. Now suppose a person whose mass is 100 kg, he is on the surface of the Earth, 100 kg, right? And in a spaceship he is going towards the Mars. And on the Mars, see, on the Mars, when it reaches to the Mars, its weight will be 400. Okay, 400 Newton. Okay, and here on the Earth surface the weight is 1000 Newton. Identify from the below figures the curve that fits best for the weight of the passenger as a function of time. See, as a function of time, that means, as it goes towards the Mars and all. Okay, that is the thing. See, as time progresses, As time progresses, this 1000 Newton has to actually reach up to 400 Newton, right, on the surface of that. So as time progresses, you know, they will have attraction since this has smaller g and this has greater g. That means, you know, there will be imbalance in the force of any object. Suppose if the person is here, the attraction by the mass will not be exactly equal in magnitude of the so the magnitude of the force of attraction by the earth will not be same as the mass. Okay, so there will be always resultant value of the force of attraction, but there must be a point where the attractive force exerted by the earth and the attractive force exerted by the Mars must be same. Okay, at certain distance, okay, between them. So that point will be called as neutral point, and at that neutral point, the G, since there is no gravitational attraction at that point, so I can say G will be 0 at that point. So the weight also will be 0. Okay, since the attractive forces are cancelling each other at a certain point, that is called neutral point, there the G must be 0. Okay, G must be 0 at that point. Okay, and look which one is depicting the same thing. See, this is giving you 0 value here, and thereafter it will just move. See, thereafter it will increase to 400 Newton. Look this one. See this C. At certain point it will actually decrease continuously, and even it will go to 0 at certain point where the force of attraction by the earth and force of attraction by the Mars will be same but opposite in direction. Magnitude wise same, they will cancel each other, so there will be 0 force of attraction. So weight of the person will actually feel weightlessness. Okay, thereafter as it moves further towards the Mars, then it will gain further some weight, and on the surface of the moon it will be 400 Newton. So that is what it is, the graph which is depicting it correctly. So C, so first option will be the correct answer for this question. Now let us go to the, okay, so up to this actually there are questions from first shift. Okay, first shift. Now we are in second shift. Okay, the questions from now I'll discuss from the second shift on the same day. Okay, 20th July. If the kinetic energy of a moving body becomes 4 times its initial kinetic energy, then percentage change in its momentum will be. Look, I know the kinetic energy. Let me write that as K itself. We know P square by 2m, right? For any object. Now change has become 4 times. Okay. Let me just take this derivative of, just take like percentage change in the momentum. So let me take ln and then take the derivative with respect to k and p itself. So as you do in case of percent error. So in this case also, if we do that, so delta k by k will be 2 delta p by p. Okay, 2 delta p by p. So if I multiply 100, then it will give you percentage change. So delta p by p, this will be half into delta k by k. Okay. If I say initial kinetic energy is some E, if I write the initial kinetic energy to be K is equal to E, and then so this is initial, final kinetic energy is 4E, becomes 4 times, right? So this delta K will be actually 3E. Then I get half into 3E divided by E. Okay, divided by E. Fourth time its initial kinetic energy. Okay, let us see what we are getting. This will be actually 1.5. If we multiply 100, what we get? Okay, so this seems to be incorrect. Let me check once again. Okay, let me just clean everything. So it is maybe this one. Let me check. This k is equal to p square by 2m. Okay, so if I take ln, this is not a quantity which can change. Okay, this is constant quantity, so I'll go for this change in the momentum, percentage change in the momentum, delta p by p, fractional change. So this is ln k, that means k delta k by k. Okay, this is actually ln, so delta p by p only. Delta k by k. If the kinetic energy of the moving body becomes 4 times its initial kinetic energy. This is only the percentage change. Okay, let us do one thing here. Change in the kinetic energy. It becomes 4 times, right? 4 times. Let us read the questions once again properly. The question is saying, if the kinetic energy of a moving body becomes 4 times its initial kinetic energy. If the kinetic energy of a moving body becomes 4 times its initial kinetic energy, then I see. Let me just check. Four times its kinetic energy. P square by 2m. K is the P square by 2m. That is fine. So here delta K by K. I think this is if the kinetic energy of a moving body becomes 4 times the initial kinetic energy. Here is the clue actually. If I say K2, K2 is equal to 4K1. Okay. Let us say this is K1. Okay, this is K1. So this is delta K. So delta K by K. Change in the percentage change in the kinetic energy. Sorry, okay, let us do this way. Otherwise, if we okay, we'll go with some other idea. So see K1 is equal to 4K2. Then we get this half M V1 square is equal to 4 into half M V2 square. Okay, so this half M I can strike out from here. Then the M V2, sorry, V2 will be equal to 2V1 from here. Okay, then what is the momentum? See, I can write delta P. Delta P means P1, sorry, P2 V2 minus P1 V1. Oh, sorry, M1 M2 M1. Okay, let me write. Delta P means P2 minus P1. That is what I have to write. So M V2 minus V1. Okay, so this will give you actually V2 means 2V1, then V1. This is actually M V1 only. Okay, now we have to write delta P by P. See, delta P by P1. Okay, so delta P I have got MV1 and P1 also is MV1. This is actually fractional change, and if we multiply 100 with this, then I'll get 100 to get 100. So to get the percentage error, so this will be actually 100%. Okay, I think this is the safest way to go with. So this is the safest way to solve this problem. So this will be 100%. Okay, this is the answer actually. We can actually cross check why we had mistake over there. Look, delta k by k is equal to 2 delta p by p. This is what we had, right? So here actually we have to take 4 times, okay, 4 times the initial kinetic energy. Okay, so in this way I should go actually. K is proportional to p square. Okay, if the kinetic energy changes by 4 times, then p must be changed by square root of this. Okay, 4 means 2 times. Okay, 2. So p1, if p1 is k, then p1 is equal to root over k, p2 will be actually 4k, that means 2 into root over k. Okay, so this is nothing but 2p1. This way we had to go. All right, so anyway we have already solved this here. You can go in the simple way itself. So 100% will be the answer actually. Now this question, this says for a series LCR circuit with 100 ohm R series LCR circuit. This is L, this is C and R connected to a battery say. So C is given as 0.1 picofarad. See, frequency of the AC voltage is given as 50 hertz, 220 volt. Okay, 220 volt, 50 hertz. The question is the phase angle between the current and supplied voltage and the nature of the circuit. So we have to find out what is the phase angle between the current and the supplied voltage, and we have to find out the nature of the circuit here. See, let me tell you this R is actually 100 ohm. What about XL? What about XL? See, XL is omega into L, which is 50 into L is given as 0.5 milli. So 0.5 milli Henry. So 25 milli ohm actually. Okay, 25 milli ohm. And this is milli Henry. Fine. XL. XL is equal to omega into L. 50 hertz. Along with that, L is given this one. Okay, this one is fine. Then what is XC? Capacitive reactance 1 over omega into C. 1 over omega 50 into C. C is the capacitance, the 0.1 picofarad. That means 10 to the minus 12 farad here. Look then what we get. This I can actually write as, so this I can multiply here. This one more 10 from here. And this will 10 to the power 11. This is having ohm unit. So this will be actually 2 into this. So look then, XC is much greater than XL as well as R. So what is the inference we are getting from here? See, we know that phi is actually tan inverse mod of XC minus XL divided by R. Okay. Now, if somehow, not mod actually, this is this one, like this. So if somehow XC is much greater than XL, then the circuit is actually this gives positive quantity. That means in that case it will be capacitive. So XC is much greater than XL, so capacitor is actually dominating. And see, this is 100 ohm, and this is actually having XC having resistance as good as 10 to the power 11 ohm. Okay, so the circuit is then what? Circuit will be actually predominantly predominant capacitive circuit. Okay, capacitive circuit. Okay, predominantly capacitive circuit. Okay, predominantly capacitive circuit. And we know in case of purely capacitive or inductive circuit, the current and voltage will have phase difference nearly 90 degree. So we'll just check here. The phase difference will be nearly 90. It is predominantly capacitive circuit. So the option 4 will be right answer for this question. Okay. Now I'll write few more questions. So these are actually from shift 2 paper. Same session, 20th July. I'll get few more questions from this shift 2. First of all, I'll write the question here. In an electromagnetic wave, EMO wave, the electric field vector, sorry, let me write in short, electric field vector and magnetic field vector are given as E is equal to E0 I cap and B is equal to B0 K cap. Okay, respectively. The direction of propagation of the EM wave. Direction of propagation of EM wave is along option A minus K cap, option B excuse me plus K cap, option C along minus J cap, option D J cap. So we have to find out the direction of propagation of the EM wave. This is a very simple question. See, direction of propagation vector of an EM wave is actually given by K vector is equal to E cross K, E cross H, E cross H or E cross B. Actually, this direction will be direction anyway. We'll get here. Magnitude, there will be some conversion factor over here. We are not bothering much about it because we have to get the direction only. So direction at least we will get from here. Okay, if you want to have the value of propagation vector, then I should have got few some mu omega or something like that will be there. Okay, either multiplied or divided. But anyway, for direction it is all right. To get the direction, this is enough. So we'll just go with this cyclic rule I, J and K. Look, the electric field is along I cap direction and the magnetic field is along K cap direction, IK. So IK is actually in the opposite direction, right? Ki is J, Ik is actually I cross K will be giving you minus J cap. Okay, I cross K will give you minus J cap. So option C will be the correct answer for this question. This was really very simple question, and this is a question of JEE main paper. All right, we'll go for the next question. So there is another question which is very simple. If you remember the formula, that itself will help you to answer in some 5 seconds. You can answer it. The question is, the correct relation between the degrees of freedom and the ratio of specific heat gamma is. See, this question is the correct relation between the degrees of freedom and degrees of freedom F and ratio of specific heat gamma is, options are, first option, this is 2 by gamma plus 1. Option B is F is equal to 2 by gamma minus 1, and then option C is F is equal to 1 over gamma plus 1, and option D is F is equal to gamma plus 1 by 2. Okay, so you have to find out the answer for this. See, it's very simple. If you remember this, gamma is equal to 1 plus 2 by F. 2 by F. This is actually the relation. Now we have to actually find out what is F from here. So gamma minus 1 will be 2 by F, right? So this will give you F is equal to gamma minus 1 by 2. I don't know whether there is any option like that. Gamma plus, okay, I think, yeah. So this is actually 1 by F is equal to this. So F will be is equal to, see, this is 1 by F, right? This is 1 by F is equal to gamma minus 1 by 2. So F will be 2 by gamma minus 1. So this option B will be the correct answer for this question. So this is very easy to remember. Gamma is equal to 2 by F. If you remember this, then it will serve your many purpose. Like if you know the degrees of freedom, you don't have to find out Cp and Cv and then get the ratio of that. Okay. Sometime you will be given degrees of freedom or any system, diatomic molecule or triatomic molecule or monoatomic molecule, and then find out what is the value of gamma. So in that case, if you can quickly calculate the degrees of freedom, then it is easy to find out gamma. If you know this formula, gamma is equal to 1 plus 2 by F. Otherwise you have to find out what is the internal energy, then you have to find out what is Cp, like Cv, then Cp minus Cv is equal to R. From there you have to find out Cp, and then you get the ratio Cp by Cv. So that is actually a long process. Okay, so better to remember this formula, gamma is equal to 1 plus 2 by F, and from there you can establish the relation the way you want. Like here you had to find out what is F, but we will be remembering the formula in terms of gamma. Gamma is equal to 1 plus 2 by F. All right, so we'll go to next problem. See, there is a problem here. The problem says two small drops of mercury, each of radius r coalesce to form a single drop. the ratio of total surface energy, the ratio of total surface energy before and after the change. So the options are given as 2 to the power 1/3 is to 1. Option B is 1 is to 2 to the power 1/3. Option C is 2 is to 1. Option D is 1 is to 2. Okay. Surface energy means surface tension into area. So we have to actually change. See, if you want to have surface energy change, yes, change in the surface energy, you have to find out surface tension anyway. It is not going to change. Same drop mercury, right? So it will have the same surface tension for both the drop. Okay. So before and after. So you have to find out what is the change in the area. So that is the uh, actually the fact here. Okay, let us try to write this. See, earlier, see, there are two drops, each of each of radius r. So 4 by r cube into 2. This is actually, suppose the new, this is equal to the volume of the new drop. Okay. So I'm just considering that the new drop has got a radius small r. So this is the volume. So this is the modified radii, because if you have two small drops equal size and then they coalesce and make a bigger drop. Okay. So this has radius smaller, say, and these each of them have their radius r. So in this case, you have to remember one fact, that the volume remains the same. So from here, we can actually strike out this 4 by 3 pi from both sides, and see this will be r will be actually 2 to the power 1/3 r. Okay, the small r is equal to. Now we know the area, change in the area. Let us see the first. See, now area is actually 4 pi small r square divided by earlier how it was 4 pi capital R square. This ratio itself will give you the answer. So this is actually 4 pi. This r is, small r is 2 to the power 1/3 capital R whole square divided by 4 pi r square. Okay. So this cancels out. Actually it is like this. Okay. This is 1. Let me just check once again whether I have written the options correctly. Yeah, these are 2 to the power 1/3 only. 4 pi r square. These are spherical drops. Surface energy. Let me cross check once again. Let me read the problems once again here, what we are getting. The question says, two small drops of mercury, each of radius r, coalesce to form a single drop. The ratio of the total surface energy before and after the change. Oh, I see. Okay, so there is a simple mistake over here. See, I had earlier two drops. Okay, so that is what we have to multiply here two. Okay, we had two drops over here, so there I have to multiply two here. Okay, so this is what actually total energy. Okay, otherwise things were all right. So we have to divide this by 2. So divide this by 2, then 2 to the power 1. Okay, this is, so this will be, this is before and after or after and before? Before and after. Okay, so let me just change a little bit here. Before and after, 2 into 4 pi capital R square divided by 4 pi R square small r square. So this is 2 into this much. Okay, 4 pi capital R square, here 4 pi 2 to the power 1/3 square R square. This R square, this R square, even 4 pi cancels each other. So here it is actually 2 to the power 1 minus 2 by 3. Okay, divided by 1, I can say. So this will give you actually 2 to the power 1/3. So the surface energy before and surface energy after ratio will be actually 2 to the power 1/3. So this ratio will be this much. Okay, so option 1 will be the correct answer for this question. We'll take up one more problem from here. Compared to shift 1, the questions from here, like questions in the shift 2, are comparatively easier. So we'll go to the next problem. Okay, so there is a problem from rotational mechanics. Okay, so let me just write the question first. A body rolls down an inclined plane without slipping. Okay, without slipping. The kinetic energy of rotation, the kinetic energy of rotation is 50% of its translational kinetic energy. Kinetic energy. The body is option A, hollow cylinder. Then ring. Option C is solid sphere. And then it is solid cylinder. What is the what is the body here? Okay, let us read the question once again. A body rolls down an inclined plane without slipping. The kinetic energy of rotation is 50% of its translation kinetic energy. The body is what? Okay, see, what is rotational kinetic energy? K rotational. Okay, let me just change the ink here. For the answer, let us change the ink. Black will take here. Okay, so the rotational kinetic energy is given by K rot is equal to half I omega square, right? And then translational kinetic energy KT is given by half m v square, right? See here, rolling with slipping is given. Okay, that means you can write V is equal to R omega. This R is the distance from the axis of rotation. Okay, so now look, according to the given condition, I know this half I omega square is equal to half m v square. Let me put what is V. This omega I can write V by R, V square by R square, that is here on the right hand side, this. Okay, so we can actually strike out this half from here, V square from here. Okay, then see, from here I'll get what is this I is, okay, m R square. If rotational kinetic energy and translational kinetic energy are same, this is the situation. But here the question was given that this will be half of the, or 50% means half only. Okay, so rotational kinetic energy will be half of the translational kinetic energy, so this half will be here. Okay, so m R square by 2. So when a body rolls down, whether it is cylinder, whether it is a ring or a sphere, see the rotation axis will be here actually. Rotation axis will be, see if it is a ring, then so this is, see through this center, its axis passes through, its rotational axis passes through the perimeter, okay, and it is actually, see something like this. It goes like this, which is a parallel axis to the original path axis or its own axis. Own axis passes through the center of mass, right? Like this. But here my moment of inertia has to be about this. So for a ring, the moment of inertia about the diameter will be mr square by 2 actually. Okay. So this is what? There are options: solid cylinder, hollow cylinder, hollow ring, etc. Okay, like hollow cylinder, solid cylinder, ring, etc. So moment of inertia for a cylinder about its own axis, will be mr square by 2, right? Mr square by 2, this is about its own axis for a solid cylinder, and see when a ring or sphere, if I say it is sphere, so moment of inertia should be 2 by 5 mr square plus mr square. So this will be the moment of inertia, okay, corresponding to this rotational motion or corresponding to this rotational axis. Okay, so this should be actually 7 by 5 mr square. For a ring also, this should be, see the moment of inertia about the diameter, okay, about the diameter will be mr square by 2 for a ring. If it is a ring, if this is solid sphere, for a ring, moment of inertia about the diameter, okay, about the diameter plus this mr square. So this should give you 3 by 2 mr square. Then see, it is not a solid cylinder, neither it will be hollow cylinder, okay, sorry, it is not a solid sphere. And what else the options are? The options are solid sphere, solid cylinder, hollow cylinder, and ring. See, in case of hollow cylinder moment of inertia about its own axis will be mr square, okay, about its own axis, just like a ring, okay, mr square. This is solid cylinder, this is hollow, and this is ring. We have got, see, for a hollow cylinder we have got moment of inertia about its own axis, because when a cylinder rolls around, this rolls around, so it will be actually the rotation will be about its actually own axis, okay. So the answer will be actually solid cylinder. Okay, moment of inertia will be mr square by 2 for solid cylinder alone. Okay, all right, here I'll stop. So the first option for this question, second option, I think, sorry, this is the fourth option which is correct. Okay, so fourth option is the correct answer for this question, solid cylinder. So we'll stop it here for today. We'll continue in the next class with the remaining questions of this 2 paper. So thank you for your patience. Bye for today.